Okay, trial number 3. I'm just going ahead with this whole prop comedy thing without the comedy, so I guess it's mostly just props. I have in front of me a sheet of paper. Another thing that I do with my students at the end of each year of science, the science textbooks that I use with my science classes are the Harcourt Science Series for elementary school students. They have a grade 1 through a grade 6 textbook. Pretty much in all of the textbooks, they end with physical science and very basic physics. They start talking about motion and energy and work and that type of thing, friction and all of that stuff. And so one of the experiments, quote-unquote experiments, that I do with my students is that I have them make an airplane, and then we talk about all of the different forces working on the paper airplane. Now, the paper airplane that I make with them is a glider type, and it was very common when I was growing up. It's one of the 2 types of paper airplanes I know how to make, but apparently in Korea they just have not seen this kind of paper airplane, because every time I do it the students are just absolutely astounded. They call it Mr. Vasek's airplane, and so just in case you haven't seen how to do it, I'm going to show you how to fold a glider. Now, on video I'm not going to be able to show you the amazing way that it flies, but with the proper technique you can throw this paper airplane so that it actually returns to you. You can throw it and catch it. Now, I've been doing it in science classes for, well, 8 years here that I've been teaching science, or 7 years here. I also have used it in my English class when we were trying to describe a process and when we're just describing objects. And so I've actually been playing with this kind of paper airplane in classes once or twice a year for 15 years, so I'm pretty good at getting it to return to me. I can usually stand in one place and throw it around most parts of the room and have it come back to me. Anyway, so you need a piece of paper. It doesn't matter what type of paper it is. It could be written on, it could be lined paper, it could be unlined paper. It doesn't really matter. You put the paper in front of you long ways. You take one of the corners, and you are going to fold the corner diagonally across so that you make a point. There we go. Now, it doesn't really matter if you make perfect folds or not, but I've found that they fly better if you don't have too many rough folds. It seems to affect how well it flies, whether the lines and creases are straight and tight. Now, it would be better to have a mistake with a nice tight fold than it would be to have it perfectly squared with rough edges. Okay, so we've taken one of the upper corners and we've taken the corner to the other long side, and we've made this shape. We take this point and bring it over to this corner, making a shape something like a house. So you make your little house just like that. So now we have, this is the fold that we've made. We start with a full sheet of paper. We take one of the upper corners and fold it to the opposite long edge in a nice tight fold. We then take the other upper corner and fold it across, making a shape like a house. Now we take this point, the top of the house, and we're bringing it right to the eaves trough, directly down below. We're just folding it in half. It does not have to be perfect. Some of my students take out rulers and pencils and try to draw lines. You can just eyeball it, but you're taking the point and you are placing it at the base of the eaves troughs there. So you've got sort of a flat house. Now this is going to be the outside of the airplane. This is the inside of the airplane. So now you are going to imagine a line down the center of the airplane, and you're going to fold to that line. Now this paper here is 1, 2, 3 folds over. So this is 2 sheets of paper, 4 sheets of paper. This is now 8 sheets of paper thick through the middle, and we're folding it in half, so it's going to be roughly 16. So this is a little tough to do. Now you want to make it as close to even as you can. I usually line up these 2 points and this line along here first, and then I squeeze very tightly here, because this part here is the hardest to fold straight, and then you just go across. And so what I've done is I've folded the plane in half, like so. So now we have from the outside view and from the inside view. Okay, now this along here is going to be the body. This is the nose, this is the tail. Now, if you make the body too small, the wing to body ratio is off and it does not fly very well. It doesn't have the necessary momentum. The wind resistance causes it to stall in the air, so it doesn't fly terribly well. If the body is too big and the wings are too small, it will fly very quickly, but it's not very good for demonstration purposes. Now, for my purposes, what works best for me is just a little bit wider than 1 finger for the body length. So you're going to take about 1 centimeter, maybe 1.5 centimeters, and you are going to fold the wing down as straight as you can. Again, you don't have to measure it, you just sort of eyeball it. So we now have the body across here. So we folded that down. This is the inside view. We're turning the plane over, placing it down, and we're matching the fold so that the wings are roughly the same. Now, this is the basic form of the airplane. And of course it was not perfect, but so much of life is not perfect, you just deal with it. Okay, so now we've got the wings, we've got the nose, the tail, the wings. Now we need to fold the wing edges up. I usually go about 8 or 9 millimeters or so, maybe about half the thickness of my finger. You fold the edge up 90 degrees. This helps to keep the airplane a little bit stable. Do the same thing on the other edge. Now comes the important part, the part that makes this airplane so tricky. You need 2 flaps. The flaps, the size of the flaps depends on the size of the wings and the wing-to-body ratio. I found that about 3/4 of an inch works for the typical pieces of paper that I use. So those are my wing flaps. I folded them up. Now, if you simply drop this paper airplane, it will, as it drops to the ground, the air resistance pushing back against it will push the nose up slightly, which will allow the air to hit underneath, which will give it a gliding motion. If you throw it completely straight out ahead of you, it should do an upwards circle. Now, the trick that I do not tell my students is that when you are throwing, you tilt the airplane at about almost a 45-degree angle. Now, if I am throwing since I am right-handed, I often throw to my left. When I'm throwing to my left, I hold the airplane like this, which causes it to turn around to the right. So it does a circle this way back to me. If you are throwing it left-handed, you would use your left hand, but you would tilt it about 45 degrees to the right rather than perpendicular. With a little bit of practice, you can get it to come back to you. A firm follow-through, but not a strong throw, is most useful. Throw it firmly, but not suddenly. With a little practice, you should be able to make it come back to you. I use it with my students to have them talk about different forces acting on it. Gravity, the force of the arm, the wind resistance causing changes in direction, all of the other factors influencing circular flight. We do experiments where we simply drop it and observe what happens, and then we do other trials where we fold the flaps in different directions to see how that changes how it flies. It's quick, it's easy, it doesn't require many materials, and it's my little physics experiment. Plus, it's kind of a fun airplane to play with. Anyway, this is now 3 videotapes for you my first day, trying it out. I love you, Cheyenne. I miss you. I think about you all the time, even if I'm not always typing. So, have a wonderful day. I hope you enjoyed seeing the videos. I think I may do this because it's easier on my shoulder right now. I hope you can watch the videos.